Hi guys, welcome to my channel. In this video, I am going to explain the remaining concepts which are there in the physiologic. In my previous video, I explained about the physiologic and some history of the physiologic and what are the knowledge soup frameworks and what is the physic control also. So in this video, I am going to explain the remaining topics which are there in this physiologic. So I think you all know what is the physiologic. So physiologic is nothing but the intermediate results between the 0 and the 1. Yes or no? So in the Boolean logic, we have 0 and the 1. The result of the Boolean logic will be either 0 or the 1. Other than 0 and 1, there will be no other result. But the completely opposite to the Boolean logic is nothing but the physiologic. So the intermediate results which are there between the 0 and 1 will comes under the physiologic. So this thing I explained in my previous video. So now let's understand more about this physiologic. I think till here I stopped. So now let's continue till from here. Okay. Yeah. So what is this physiologic? Look at here. In standard logic, every statement must have an absolute value. It may be true or the false, which I said. Like Boolean logic will be having either true or false. Will be having correct consistent result. It will be true or it will be false. Yes or the no. But in physiologic, the truth values are replaced by degree of membership. I will be explaining about this membership function also in this video only. Don't worry. From 0 to 1 means the intermediate values which are there between the 0 to 1 will comes under the physiologic. That is the main difference. Don't get confusion between the Boolean logic and physiologic. Boolean logic and physiologic is completely different. It's not same. It's completely different. Where one is absolutely true and the 0 is absolutely false. Yes or no? So 1 means yes means which is true. 0 means no means which is nothing but the false statement. So it will be absolute value as or the no. But physiologic will be having the intermediate values which are there between the 0 and 1. Now let's understand what are the intermediate values between that 0 and 1. Now let's take the example. With this example, I think you can understand more clearly about this physiologic. Yeah. So is it hot water? So this is the question. So is it hot water? Means if we use like in a Boolean logic, if it is hot water, we'll say it's yes, it's a hot water. If it is not hot water, no, it's not a hot water. It comes under the Boolean logic. Means we'll get yes or no. So correct result, accurate results. If it is hot water, yes, the result will be yes. If it is not the hot water, the result will be no. That comes under the Boolean logic. But in the physiologic, the result may be like maybe yes, maybe no, absolutely true, absolutely false, may not say, very high, very low. These may be the results of this question in the physiology. But in the Boolean logic, yes or no is true or false, absolutely yes or absolutely no. That's it. Other than this two, will not get any type of result, any type of an result. But in the physiologic, we may say like maybe yes, maybe it was hot, maybe it is hot water, like maybe no, maybe it is not hot water. Absolutely yes, it's absolutely hot water. Absolutely no means absolutely it's not a hot water. Or may not say, I can't say it's like a type of a hot water or not hot water. So may not say. Very high means it is very high level hot water, and very low means water is cool. Very high means water is very hot, very low means water is very cool. So in this way we can say, so we have many results to specify the physiology. Okay, I think you got clarity. So is it cool outside? Same, it is cool outside means in the Boolean logic we'll say yes if it is cool, yes if it is not cool, no. That's it. But in the physiologic we can say yes it is hot, sorry it is cool outside means yes absolutely yes. If it is not there, like absolutely no. Or we cannot say which condition it is, you may not say yes it's very high means it's the coolness is very high, very low cool is not, like very it's very hot, then we can say very low. Like this we can have many results. Not only this, we can have many results, not only these type of results. This is like a rough idea, but we can have other results also in the physiologic. So these are the some intermediate results which are there between the 0 and the 1. So this is some diagrammatical representation so that you can understand this. Yeah. means yes or the no. Yes means which is 1 and no means which is nothing but the 0. So these yes and no will comes under the Boolean logic. Whereas in the physiologic, see here, if it is cool means very high, means if the coolness is very high, we'll say it's very much. Then if it is moderate, like little, then we can say this one. And if it is not there, then very less. So these are some conditions which are the intermediate. That see the values of this, like 0.9, 0.25, 0.1. So these are the values which are there in the between the 0 and 1. Yes or no? So these values are between the 0 and the 1. So these type of results are known as physiologic, which are the values which will be lie between the 0 and the 1. So with these examples, I think you got a more clarity on the physiologic and the Boolean logic, when the Boolean logic will come and when the physiologic will arise. Now let's understand the physiologic architecture. So we'll be having this base, which is rule base, and from the rule base we can have the two conditions, which is fusifier and defusifier. So from the base will be, the base is divided into two types. One is fusifier and one more is defusifier, and the combination of the both comes under the engine, which is inference engine. So from this will be coming input, and from defusifier the output will be going outside. So this is the basic diagram of the, like it's like architecture of the physiologic. So I will be explaining every keyword, don't worry. So first, what is this physi? So first I will be explaining you about this base only. Yeah, rule base. What is this rule base? Let's understand. So it consists of set of rules. So means what? Here it is like a base of the fusifier and the defusifier. Means in this base we'll be having all set of the rules which we have to follow, and if then conditions, like if this is there, then what we have to do, like you know about this if then conditions, when this if then condition will be arising. So if this there, then what we have to do. So that type of scenario. So these conditions can occur and provided by the exposed to ground the decision making system. Okay, to make a decision we'll be having some rules and if then conditions in this rule base. Okay, so in this rule base we'll be having all types of rules, or all set of rules which we have to perform, and this rule base is divided into two types, which is fusifier and defusifier. Fusifier is also known as fusification, so which is nothing but it is used to convert the input crisp numbers into the fuzzy set. Yes or no? Means what? From this the crisp input will be coming into the fusifier, which is nothing but the fusification, and it will be passing to the fuzzy input set to the this inference engine, which is nothing but the intelligent. Okay, like in this engine it will be passing the crisp input will be converting into the fusification, and it will be passing to the engine through the fuzzy input set. So this is the process. Yes or no? And the scripts inputs are basically the extract input measured by sensors and passed into the control system for processing. So these inputs, this crisp inputs which are there, it will be passing to the fusification, and it will be going to the input sets to the engine, inference engine. Okay, such as like temperature, pressure, RPM. Now next, what the inference engine will be doing, from this input fuzzy set it will be passing to this engine, and from this the output fuzzy set will be going to the defusifier. Okay, yeah, look at here, it determines the matching degree of the current fuzzy input. From this fuzzy input the fuzzy input sets will be coming towards the inference engine, and with the respect to each rule what is passing, the rule which is passed to this fusification, and decides which rules are to be fired according to the input, means which rule is appropriate to the particular input. Okay, and next the fired rules are combined to form the control actions. Okay, it's very easy, and it's very easy to understand also, simple English words. Yeah, next, defusification. What is the defusification? So from this output fuzzy set it will go to the defusification, and from the defusification to the crisp output. Okay, yeah, it is used to convert the fuzzy sets, which is output fuzzy sets obtained by the inference engine. So from the inference engine, what the input fuzzy sets are coming from, that fuzzy sets, the output fuzzy sets will be exiting. Yes or no? So yeah, these are the several differentiation methods available, and the best suited one is used with a specific expert system to reduce the error. So why this all, like why this architecture was used in this physics says, because to reduce the errors. So the rules which are there, the rules basically divided into two types. Now look at you. So these are the basic rules which are there. So in this basic rules we have all types of instructions which we have to follow. So that rules will be distributed to the fusifier and at the same time defusifier also. So the fusifier is nothing but the fusification, and defusifier is also nothing but the defusification. And from the input, the crisp input will be coming into the fusifier, whereas from the defusifier the crisp output will be going out. The output will be going out. Here the input is coming inside. Okay, from this fusifier, the input fuzzy sets which are there, that will be going into this engine and it will be doing its process. And after the, and the rules which are there here, it can directly go to the engine also. This facility also is there. Okay, and from this engine the output fuzzy sets are came out, and these will be converted into defusifiers. And from this defusifier, the output set, the output fusifiers will be coming out. The crisp output will be coming out from the defusifier. So this is the whole architecture of the fuzzy logic. Okay, now let's understand what is the membership function. So a graph that defines how each point in the input space is mapped to the membership value between the 0 and the 1. So actually the physics set is not the 0 and the 1. It is the 0 and 1 with including with the intermediate values which are there between the 0 and the 1. As so no. So next. So input space is often referred to as the universal of discourse or universal set, or we can say simply universal set. So this is known as in universal set. So this is known as universal set, and which contains all the possible elements of the certain in each particular application. So this is a representation of membership function. So this is a representation of membership function. How to read this thing? So it's like physics set A means this is a universal set. It is a universal physics set A. So this A is a set A, and which is mapping to, this is the mapping to, so this physics set which is mapping to the 0 and the 1. So 0 and the 1 means the physics set A on universal means this is a universal. So the physics set A on universal of discourse X is mapped to 0 and the 1. So in this way we have to read. How to read this? The physics set A on universal of discourse X is mapped to 0 and the 1. So the values which are there between the 0 and the 1. So this is represented in the square brackets, means the values, the 0 and 1 is also included. If we use the normal brackets, the 0 and 1 is not included, but here we have used the square brackets, means 0 and 1 also included. The values of 0 and 1 is also included. At the same time, the values which are there in between the 0 and 1 also there. So the A is nothing but the set, and X is nothing but the disclosure, and this new is nothing but the universal. Okay, this is the representation of the membership function. Now, so we have generally like three types, which is singleton fusifier and Gaussian fusifier and triangular fusifier. So this thing is not that much important, but remember what are the types of this fusifier. That's it. It's enough. And this is the graph. This is the graph representation of the membership function. So look at here very carefully. So we have here we have the positive signs thing and negative sign. So look at here. Here the point is 0, and here we have 5 and positive 5 and positive 10. Here the negative 5 and the negative 10. So sorry. So here the positive thing will be there. So which is MP and LP. So this side the negative symbols are there. Yes or no? So this side the negative symbols are there. Means MP means medium positive. LP means large positive. MN means medium negative. LN means large negative. Means so how the graph is there. So first look at here. So from initially the point is which is constant, and this large negative, this is the large negative, this point is known as large negative. This large negative is slowly decreasing. This large negative is slowly decreasing and reaching to the zeros position, and after that it's slowly increasing its position and it reaches to the small place like small point, and again it starts decreasing. Yes or no? And again it starts increasing to the large positive. So this curve is known as large negative, small, and the large positive. So this is the negative side and this is the positive side, and this is known as the large point. So this is known as a large point. Okay? Yeah. And again from the medium negative and the medium positive will starts and ends with the zeros position only. So it is starting from the zeros position and it goes on increasing at the peak point where it reaches to the medium negative. It starts decreasing to the again zeros position, and after reaching to the zeros position again it starts increasing its position too. So again it starts increasing to the medium positive level, and again it starts decreasing. Okay, and it reaches to the zeros position. So see the color difference. So the orange color curve is nothing but the large negative to the large positive, and the purple color is known as the medium negative to the medium positive. So see the difference between this both curves. So the medium negative and the medium positive starts with the zeros position and ends up with the zeros point only, whereas the large negative and the large positive starts with the 1, and here it starts with the 0. See this difference. So medium positive and the medium negative starts with the 0, whereas large negative and the large positive starts with the 1 and ends up with the 1. See this difference. Okay, this is the difference between the large and the medium and the small. Okay, so the small will be at the first position only, and the medium will be at the zeros position, starts at the zeros position and reach the 1 position, again start and decreases to zeros position, again reach to 1 position, and again goes down to the zeros position. So similarly the large positive and large negative also will start with the 1, and for some duration of time it will be constant. Initially at the end stage also at some duration it will be constant. So this is the basic membership function diagram graphically. So understand this. So now let's understand what are the advantages and the disadvantages of this physiologic. So first advantage is it is easy and understandable. So this physiologic is very easy to understand. Yes or no? So anyone can understand, and it is very easy also. Okay, and it is easily modify. If you want to modify any type of a value in between, we can easily modify. Okay, and inexpensive. It is not that much expensive. It is inexpensive sensor only. Okay, and the cost is very low. Uncertainty result, this is very important. So we'll not get the certain results, we'll get uncertainty results. Okay, and in the control machines we'll be working with the control machine systems. Yeah, and it also performs a robust behavior, means no precise input. So precise input is not there, and this physiologic is used for the practical purpose. One more thing, it is the acceptance method. What is the acceptance method? It's like taking the best out output from the multiple outcomes. So from the multiple outcomes choosing the best one which is suitable to the particular condition. So that is known as the acceptance method. So this is the one of the feature in the physiology. So these are some advantages of the physiology. Now let's understand what are the disadvantages of this physiology. So disadvantage is nothing but the not accurate always. So we'll not get the accurate results. Always means we cannot say we cannot get the correct results, but always we cannot get. Always we cannot get the accurate results. Sometimes we may get, sometimes we may not get the accurate results. Yes or no? And cannot recognize machine learning and neural network patterns. So this main disadvantage is in this physiologic. So it cannot recognize the machine learning and the neural network patterns which are there, it cannot recognize. Okay, and it is expensive testing. So to while validation and verification, it is very expensive in the testing. Okay, and the rules and the membership functions is difficult. So which I explained, the architecture, the rules that should be very informative so that it can be divided. It can be divided into the fusifier and the defusifier. So that one and the membership function which I explained with this graphical explanation. So this. So rules in this membership functions are difficult. And that's it about this advantages and disadvantages. And what are the applications where we can use this physiologic means in the aerospace fields. In the aerospace fields we can use in the control systems and the traffics, in the place of the speed and the traffic also we can use to control the traffic. And in the decision making support systems also we can use, and chemical industries also we can use NLPs, neural and modern control systems. So in this way we can use this. So these are the applications of this physiologic. And this is that's it for this video. I think you understood about this physiologic. And still if you have any doubts in this physiologic, please be free to mention in the comment section. I will be definitely solve your doubts. And that's it. And don't forget, like, this is very important for the mainly examination point of view. So when you are preparing for your examination, so don't miss this topic. This is very important. This may come in the examination. So and in my next video I will start this non-monotonic logic, and this is also one of the important concept. And that's it for this video. Thanks for watching. Let's meet in the next video.